Here's your integrated 3 video lecture for 11.2.3. What is a solution in 3 dimensions? Solving systems of 3 equations with 3 variables. So since we aren't together in class, you're not going to be, what they first have you do is try to solve the system graphically, which you'll find out is the hard way, and you won't really be able to tell what the solution is. And then they go ahead and kind of walk you through how to algebraically solve a system. I think that you guys probably know enough about systems of linear equations to be able to understand this. So I'm going to do some of these problems on 11-7-9. But before I start doing these problems, I want to point out that since we're in 3 dimensions, sometimes, you know how like when you have 2 lines, maybe they're parallel and you get no solution? Things like that can happen in the plane. Like this could be 2 planes that intersect in a line. And you could have 3 planes that intersect in a single line right there. There's ways that they can be tilted, the planes can be tilted so that they intersect in just one point. Sometimes there's just no solution because the planes are parallel. And so since it's so hard to show you that with paper and it's just about impossible to draw it, I have a computer animation. It's just a YouTube video that's 2 minutes long that I'm going to put the link for it in your Google Classroom so you can check it out. But just know as you're doing these problems that sometimes your solution won't just be a point. It might be something else. So I'm going to do letter A. I have a certain way that I always do these. I like to use elimination. Sometimes it's called linear combinations. I think you guys call it elimination in your textbook. So usually what I do is I'll take the top 2 and I'll look at them and see if there's something that looks like it might be easy to eliminate. So I see that my y's, if I just multiplied, I don't know, the top one by negative or the bottom one and added them, I would be able to eliminate the y. So I think what I'm going to do is I'm going to make this whole top part, I'm going to multiply it by -1. Okay? And I'm going to do the whole thing in my mind, I hope. I'm going to say, I'm adding it to the second equation. So I'm going to say -1x plus 2x, and I'm just going to write the answer. What's -1x plus 2x? It's x. What's -y plus y? Well, it's nothing, right? So I eliminated the y. What's -1 times 3z? That's -3z plus 6z gives me 3z. -1 times 3 is -3 plus 2 is -1. So what I did is I have 3 equations and 3 unknowns. I took 2 of the equations and eliminated one of my variables so that now I have an equation with 2 unknowns. So I have to make sure when I do these, I'm going to just do these 2. I want to eliminate, here I eliminated y, so here I also want to eliminate y. It'll be very easy to eliminate y here. All I have to do is just add the equations together. 2x plus 2x, I'm just adding these equations. It's 4x. Y plus -y is nothing. 6z plus 3z is 9z. And 2 plus -7 is -5. So now I have two equations with two unknowns. And you guys might already know how to do this. I could probably multiply the top by -3 and get rid of the 9s. Or I can multiply it by -4 and -3 and get rid of the z's. Or let's just multiply the top by -3 and get rid of the z's. So let's say that this is, or we can rewrite it too. This one's going to be multiplied by -3, and I'm going to write it down here. -3 times -1 is 3. And I'm going to rewrite this one underneath it. See what I did? I multiplied that by -3. And then I just wrote it down here. And I wrote this one down here. And then I'm just going to eliminate the z's. And I have x equals, so now I know what x equals. So I think I could plug x in right up here and get z. Let's see. -2 plus 3z So if I bring the 2 to the other, -2 to the other side, I think z equals 1/3. Let's see if that's right. Yeah. So, and then I can just plug in x and z to find y somewhere. And I see that this top equation would be easy. So x is -2. I'm looking at this right here. -2, and y is, we don't know. And z was, well, 1/3 times 3 is just 1. Right? Oh. -2 and +1 is -1. Well, here. Okay, so I can write this as an ordered pair. X is -2, y is 4, and z is 1/3. And so these three equations, these planes actually were configured in such a way that they met at a point, and this is your point. Now, I don't want this to be super long video, so I think what I'm going to do is just kind of walk you through what would happen. You've got to try some of these. This one should turn out fine for you. This one will have, you can probably work it exactly like I did this one. This one, something's going to happen to you when you start trying to eliminate stuff. When I take these two and start eliminating them, if I I don't know, subtracted the top one from the bottom one or whatever, I would get 0 equals 60. And that's not true. And you know that when that happens with two equations and two unknowns, you just say no solution. Okay, and that's the same thing you're going to say this time. When something like that happens and you end up with this and all your variables went away, just say no solution. And it's because the planes, they don't all intersect together. Probably one or more, or two or more of them are parallel. And then something fishy will probably happen with this one. You'll get, you'll be working through, maybe you'll add, maybe we should do this. We'll do this one real quick. So if I add these, or if I subtract, I'm going to subtract the bottom one from the top one. So 6 take away 6 is nothing. 4 take away 4 is nothing. Z take away 2z would be -z. And 12 take away 12 would be 0. So I got z equals 0. See how they had z equals 0? And then, what's this going to be? Oh, 6, so it says 6x plus 4y equals 12 when z is 0. So when I plug in 0 for z anywhere else, I get 6x plus 4y equals 12. That's actually the equation of a line. So just know that, I mean, a lot of the time the problems you get, you're just going to get one of these nice ordered triples here, but sometimes you'll get no solution, or you'll get a funny solution, like your solution will end up just being a line. And if you look at the video that I'm going to put up on Google Classroom with the animation, you'll see what that looks like when two planes are intersecting in a line. Okay, I think that's all I have for you for 11.2.3. So good luck with that.